Okay, I'll get started. Thanks for coming along. Um, we'll just have a session for perhaps an hour, perhaps a little less, and there'll be time for questions at the end, so please save them up. We will be recording this. I don't think any of you will have your cameras on, but just in case you don't want to be recorded, please don't put your camera on and have yourself in the image. We'll put the recording of this tutorial up on our YouTube channel, which I can send out if you want later on. I want to begin by acknowledging that I work on Wurundjeri country, the traditional owners of the land that I live and work on, and I pay my respect to their elders past and present. So regular expressions, I think, really do improve your life immeasurably, and I'm not joking really. I think that they can really do great things for you. You can learn to do lots of interesting manipulations of text. You can convert text, you can search for text based on structural characteristics of it and not on the content of it, which is the way we're normally used to looking through text. I sent this cartoon out from XKCD Comics, but here it is again. Just regular expressions can be a bit sort of dry and boring, but I think this gives it a little bit of a zing. So text, computer-based text has characteristics we can use, and we can use it to query the text and to manipulate the text. So we need to change text to different formats. Once we can identify elements of structure in documents, that is, spaces, carriage returns, tabs, all these kinds of things, we can automate processing and presentation of the data. And regular expressions allow us to do this. They allow us to look at structural properties of text that we work with. Why would you want to do this? Well, you may download large files from the internet that are in formats that you need to change. There may be stuff in the text file that's regular, in its where it's located, and you need to pull it out and delete it. If you want to format a document, you can use the structure sometimes to get a clue about things that need to be formatted in certain ways. So headings may have certain characteristics you can use, and you can then decide to make them bold or whatever you want to do. You may want to count all the words in a textual collection, and you need to somehow pull out all the unique words. Well, regular expressions can do this, and you can list all the words in a text. And perhaps really importantly for much of the work that many of us do, it is converting text from one format to another. So you have a tool and it gives you some output in a particular format, but you have to get it into another tool and it wants the text in its own format. And so you're able to use regular expressions to do those changes. And also you can search for patterns, but not for particular content. And we'll look at examples of all of this soon. So for example, in the blue box, I've downloaded a list of all the files in a data set, and there are actually 500,000 of these file names. And what I want to do is just pull out the MP3 and WAV file names. So that's something that regular expressions let me do. So I can get this converted into this format. Something that linguists perhaps more than others might want to do, but here's a dictionary on the left. This was a Microsoft Word document, and I needed to convert it into structured format like this to be able to use it in modern dictionary software. And regular expressions let me change this, for example, this entry, arbor here, arbor, from this format into this format. And that was by looking at this the form here and seeing that this is in bold, so I can search for a bold word at the beginning of an entry of a line and make that into the head word, which I've put an LX next to. And then this ka is some kind of other information I've put into this field here. And so you can see you can structure this information, and this is done using regular expressions. This is a Somali dictionary. It was 26,000 entries. So the thing is, you don't want to be doing these things by hand. You want to be doing them over the whole data set, and you can do it relatively quickly using regular expressions. Another example of a dictionary file, again, here's the Word document, and this is the structured format we want to end up with. And you can look for things like the beginning of a line that has an asterisk. That tells you that it's the beginning of an entry, and that's what then gets converted into the form you need over here. Now you can do these changes over documents, but you have to be very careful. Because you're operating remotely over a big document, you can do terrible damage. So you should always make copies of the file that you're working on, and if you're doing big changes, you could probably save your file every time you do a change so that you can go back. Some software, of course, lets you undo, and if you're confident that your software lets you undo your previous change, then you're safer. But be very careful because you can do massive damage with a regular expression. First thing you have to do is look at the structure of the document you want to work on. You have to turn on the invisible characters, the spaces, the tabs, and the carriage returns. And then you've got to look for the regular patterns that you're interested in that you want to target. So for example, here's a text file and I want to work on this file. First thing I should do is turn on the view of spaces and carriage return. So this structure then is more apparent to me, and I can see that I have a pipe followed by spaces and a number, followed by a space, followed by space and text and spaces and a pipe. So this is the sort of structure that we can address using a regular expression, and it can just go through line after line and do something to it if we want to. Regular expressions are found in lots of different software, but perhaps most familiar to you would be Microsoft Word. Word has two different regular expression languages. And one of them is using the special menu. So here we've got Microsoft Word. If you go to the Find and Replace dialog in Microsoft Word, one of the things you can search for in the special menu are all of these things here. So the paragraph mark, the tab character, the comment mark, each of these is a regular expression. So you can then use this in Microsoft Word to look for a paragraph mark and then to insert something there, or a tab character and delete it, or whatever you want to do. So that's one kind of special menu in Microsoft Word, but Microsoft Word also has something called wildcards, and you can see that here on the Find and Replace dialog. And it, unfortunately, has a different set of regular expressions, and you can't mix these two. So it takes a bit of getting used to, but you can look for things like the beginning of a word, the end of a word, not something. That can be quite useful. 0 more characters, the previous one or more. So these are all forms of regular expression, and you don't have to learn what the expressions are. You can just insert from this menu, and that's in Microsoft Word. So here's an example of using those expressions in Microsoft Word with that document that we looked at earlier. What I want to look for is a carriage return followed by an asterisk, and using Microsoft Word's special menu, I can look for a carriage return, and in Microsoft Word that is caret P. That's looking for a carriage return, and then there's an asterisk, so it's looking for the asterisk straight afterwards. And I'm replacing that with the carriage return and an LX space asterisk, and that gives me this output. The other thing that you can do in Microsoft Word is search on formatting. So if you've got a document where the formatting is done consistently, you can look for something that is italics or bold or the font size or whatever you want. So here we can look for example, a style, a bold character. So then we're not looking for any particular text, we're just looking for something that's bold, and that's what it's finding. So you can go through a Microsoft Word document just looking for formatting, and then you can operate on the found object that you've got, the found piece of text. There it is looking for an italic. Here it is looking for anything that's 12-point italic, and that's what that is. and then it's inserting a part of speech marker. So this is a part of speech in a dictionary. It's inserting a marker in front of that to say this is a part of speech. So it's making an explicit textual version of something that's implicit here. So the formatting is something that we can see, but it's not explicit in the text. And by inserting that PS marker here and here, that makes this a better and stronger textual document that we can then use in other software as well. LibreOffice and OpenOffice have much more fully featured regular expression languages. So in LibreOffice, it's called the Alt Find and Replace. So you have a normal file find and replace, and then the alternative find and replace. And that has all of these functions in it. You can look for a paragraph, a tab, empty paragraph, end of paragraph, and so on. So it gives you the textual version here, but it also has the code. So after a while, you'll learn the codes. It's not that important, but that's what gets inserted into the find box and then helps you find those particular things in the text. Now, regular expressions, regex and grep are all basically the same thing. So you'll find in different software, they'll call them different things, but these are all basically the same thing. One of the problems also is that there are lots of dialects of regular expressions. So we just saw Microsoft Word has 2 dialects that it uses itself, and then LibreOffice has its own dialect, and then all kinds of other software have their own kinds of regular expression languages. A lot of programming languages, Python, Perl, all use regular expressions as well. And so there is a sort of almost standard set, and that's what we'll be looking at today. In BBEdit, this is software for the Mac, the search has this checkbox, regular expressions. If you don't check that, then it will look for literal text, but if you check that, it will look for regular expressions. And you can see here you've got grep, in BBEdit, and in OpenOffice you've got regular expressions. So what are regular expressions? This is an expression. This is going to look for any one of the characters X, Y, or Z. So when you have square brackets, it will look for anything that's inside those square brackets. If you want to look for anything except those characters, then you put a caret at the front of the set. So you have square brackets followed by a caret, and then anything that's inside that square bracket is not to be found. You can also use ranges within square brackets. So now within the square brackets we've got a range of A to Z, and this language understands that means all lowercase alphabetic characters. If you wanted to look just for vowels, you could do that, looking for this set. And if you wanted to look for anything that was not a vowel, then you could look for this set. So you can see immediately that for a linguist, it's quite wonderful that you can look for various kinds of patterns of letters in words. This expression looks for lower and uppercase A to Z and 0 to 9, so any alphanumeric character. And now you can also look for something that's neither a vowel nor a digit if you want, because it's got not vowel and not 0 to 9. You can also look for any word character or any not word character. Now there are many cheat sheets around for these, you don't have to memorize them. This will let you look for any character except a line break, that's just the full stop. The caret at the beginning of a line, the caret means the beginning of a line, except when it's inside square brackets, as we just saw. Okay, it's confusing, but that's the way it is. So when it's not inside square brackets, it means the beginning of a line. And dollars in OpenOffice means the end of a line, but in other software you need to put the line break, which is \r or \n. So you have to learn the particular variety of regular expression that you're using. That's the Unix line break. So these are all different ways of talking about the end of a line, and you have to experiment to see which of them works for the particular tool you're in. \t is a tab, \f is a page break. Now, because we're using backslashes here, and they're part of the regular expression language, if we want to look for a backslash, a real backslash, a literal backslash, then we have to use backslash backslash. That is, it's telling it this is a literal backslash. When you find something, that whole expression that you've looked for can be replaced with itself. And if you put the ampersand into the replace box, it will replace exactly the thing that you've just found. So if you want to add something to the thing you've just found, you can use the and in the replace box. Then you can enumerate how many of the things that you're looking for there are. So you can look for 0 or more. So backslash S is a space. Backslash S with an asterisk after it is 0 or more spaces. Question mark means 0 or 1. So looking for M question mark, we'll look for 0 or 1 M. And plus just means 1 or more. So 5 plus will find a string of as many 5s as there can be in the document next to each other. You can specify exactly how many times you want to find something. So you look for X and you put curly brackets around it, the number, and it will find it exactly that many times. You can look for at least that many times, and you can look for at least but not more than these times. So you can look for something that occurs once but not more than 3 times. So using these expressions, if we look for any character, any number of them, in 4score years, we will find the whole expression 4score years, because it's saying look for any character and any number of characters. If I look for anything that is 0 to 9 and any number of them in this expression, it will find just this 1983, because that's the only string of numbers in that sentence that we're looking at. If I want to search for backslash D, which is any digit and any number of them, in this expression it will find 12. If I look for capital A plus in this text here, then it will find all of these A's. And if I look for this A, it will find just the first A, and then the next one, and the next one, and so on. But if I use A plus and look in Ted joined AAA yesterday, it will find the triple A, and then it will also find the A in yesterday. So you can search for different parts of words. Look, there are many ways you can use regular expressions, and there are lots and lots of resources. So the tools that are freely available are OpenOffice and LibreOffice. And as you saw in Word, it's not a very good regex, regular expression language. BBEdit on the Mac is excellent software for doing this, and Notepad++ on Windows. So there are many resources available on the web, all kinds of cheat sheets which list regular expressions, and you can see they deal with different languages. So you have Python, you have Java, there'll be Perl, there'll be all kinds of different languages, but basically it's all the same kind of thing. And there are more sites there, which I set out in the email. So let's try some of this. If we want to look for a selected set of characters, what we've got here is an expression, and you're familiar already with the square brackets. So what we're looking for inside the square brackets are not, tab, or carriage return. And it's got a plus after it, which means any number of characters that aren't a carriage return or a tab, followed by a tab, and then followed by another set of characters which aren't tab or carriage return, and then followed by a carriage return. So this is looking at some tab separated text, one piece of text followed by a tab, another piece of text followed by a carriage return. One of the things that you haven't seen yet is using brackets. When you put brackets around an expression here, it means this is going to be something I'm going to be able to refer to as the first part of this expression, and this is the second part of this expression. So that's number one and that's number two. And I can then go back and swap the order of these two things. So now what I've done is I've said, put number two first, put a tab in, put number one next, and put a carriage return after it. And that's now swapped the order. Why would we want to do this? Well, I don't know if you've ever been in the position of having a list of people names and you need to alphabetize them by their surnames. So here you've got a list of names and it's given as first name space second name. And what we want to do now is find the name and swap the name around. So what we do is we look at the structure of this, and what we have is text followed by a space, followed by text, and followed by a carriage return. So we can set up the expression like this. The beginning of the line is the caret, followed by any number of non-space characters. So that's all of this part. Non-space, any number of characters, followed by a space, followed again by any number of non-space and non-return characters, right? We don't want it going past the return, followed by a return, and then we want to put them inside brackets to say we're going to do something with 1 and 2. So then this expression looks like this. Okay, so it's the beginning of a line, it's not a space, and it's any number of not spaces, followed by a space, followed by not space or return, and any number of them, followed by return. And then we want to change that. So we want to put the second one first, we want to put a comma after it, and then we put the first one second and a carriage return. Now I can actually, let's have a look at this in real life. Okay, so here we are. We have the list of names, and what I'm going to do is try that search expression that we just looked at. If I can find it. Now, we want to find, so I'm in BBEdit now, and I've put that expression in that we just looked at. And what I'm doing now is that you can see that as I hit search, it's going through and finding each of these names. And what I want to do is replace it with the second one followed by a comma, followed by the first one, followed by return. And now if I just apply that to everything, it's gone through and found that and changed it with everything except this one. Now, the problem with that one, you may be able to see, is that it has a space before the carriage return, and that stopped the expression working. So you have to be really sure about, now if we go back and reapply that search to that item, it will find it. So you have to be very sure about the structure of your document, and it's worth trying a few expressions first to see if they work before you run it over the whole document. So what we've got now here is, excuse me, a whole document in which everything is ordered, has the surname first. We can then search, we can then sort that, and now we have exactly that list, but sorted by surname. And if we want to, we could now use the same regular expression procedure to switch the names back. So we would have them ordered first name, second name, but they would be ordered by surname as well. Now, so here's the other example that I showed earlier. I have a list of 500,000 file names like this, and I want to extract just the file names that have MP3 or WAV at the end. So I turn on, first of all, I turn on the spaces and see that there are spaces in here and carriage returns at the end. So what I will do is search for these spaces. So search for any number of spaces and replace that with a carriage return. So that then gives me a list of all of the files in one list instead of being spread out across the page like this. So what I'm doing is looking for any number of spaces, replacing that with a carriage return, and that will then flatten out this list and give it to me like this, which is much more amenable to the next expression that I'm going to run, which is to look for, okay, so now what I'm looking for is the beginning of a line, anything that isn't a carriage return, any number of them, and then anything that's not a 3 or a V. Now remember, what I'm looking for is an MP3 or a WAV file. So the last character of this line for what I'm interested in shouldn't be a 3 or a V, and then a carriage return. Now if I search for that, what it will do is find all the rest of the files, and I can delete them, and it will then just give me a list of all of these files, which are the MP3 and the WAV files. Some of the other operations that you can use regular expressions for, you can change the case of a character. So you can, if you put a \u next to a character, it will make the following character uppercase. If you use \U, it will make all the following characters uppercase until they reach another case specifier. You can make all of the next, similarly with lowercase. And for any of these, you can end the case transformation at some point using \E. So this lets you just go in and change particular characters. Another example, what I want to do here is so this is a project which uses these words, and it has the words in Aboriginal languages as well. It's our 50-word website. What I need to do is to create a name out of this, a file name out of the English that has no spaces, no punctuation, and no uppercase. So and then I need to put that into the file name over here. So welcome has to become C25, which is a code relevant to this, with an underscore and the word welcome.wav. So I can do this using regular expressions. I can look for anything that's uppercase, and using this expression, so this is saying anything that's uppercase, so A to Z uppercase. That's an expression which is number 1, and I want to replace that with itself made lowercase, and the \L is going to make that lowercase. So that's now gone through, and if we just have a quick look back, we've got Southern Cross, and we've got Seven Sisters and Milky Way, which have uppercase. And then if we apply this, it's now taken out, it's now converted those to lowercase. Look, I'm going to skip this one because it's complicated. Another example, just to show you what you can do, is to look at a big textual transcript, so Hansard, which is the transcript of Parliament. And for instance, you've got the word JobKeeper, and you want to find 5 words either side of the word JobKeeper inside this document, which has, tens of thousands of lines of text. So the expression you can use, expressions are always harder to read than they are to write. So let's just try and go through this and see if we can figure it out. Actually, we can look at it in real life here as well. So we'll look at this House of Representatives, and here's the expression. So this is looking at a document that has it's parliamentary proceedings, and I'm interested, for some reason I want to look for just the 5 words either side of JobKeeper, but I could specify 10 words or 20 words or whatever. So here I am looking for a word, and that is spaces followed by characters followed by spaces. So it's not perhaps the best way of identifying a word, but it will do. And then 5 of them. The word JobKeeper, and then the same, looking for spaces followed by letters, and this is uppercase and lowercase, followed by 5 of them. And you can see that it's found that particular set there. And in this software I can also find all of them. It might just take a minute to do this because there's a lot of material in this file. But it will then give us a list of all of the mentions of JobKeeper and all the characters, the 5 words around it. So it's a sort of concordance function, which can be quite useful if you're looking for, you could be doing sentiment analysis and trying to figure out what kinds of words collocate, what are the words that go around JobKeeper, and then you can do some analysis on that. You can see it's taking a while to chug through this document. But this is what it ends up looking like. You can have a span of text together with all the information around it. So 0 or more spaces followed by A to Z, so any alphabetic character, and 5 times that previous item. That gives us 5 either side of the word JobKeeper. And there it is again. Okay, so what I'll do now is invite you to ask any questions. I know that covered a lot, but I think the thing is I wanted to just give you an idea of what regular expressions can do. So please feel free to ask any questions. Unmute yourselves if you want to.
Hello.
Hello?
I was thinking, I was wondering about the example of the first list of names, which were not in alphabetical order.
Yep.
Well, after I do that job, if I want to put these names in alphabetical order, I inverted the order, putting the surname before the name, and now I want to organize alphabetically. How could I do that?
Yep. So that was in this list.
Yeah.
Now that we have it in alphabetical order by surname, we can convert that back. You're saying, how can I put that back into first name, second name? Is that right?
No, in
Sorry?
okay. It's already in order. I thought that.
So this is what it was like before.
At the beginning, okay.
Yeah, that's what it was like at the beginning.
Okay.
And we then did the operation and changed it to this.
Okay.
And then sorted it. So that's just using an ordinary sort.
Okay. Easy.
Yep.
Easy.
I mean, one of the things to think about too is that some of these operations could be done in other ways. You might want to paste things into Excel and do them in there. There are many different ways of operating on text. It's a question of learning which one you like best and which one will work most efficiently in a particular circumstance.
Okay. Thank you.
Yep. Any other questions?
Hi, Nick.
Hi.
Thanks for the useful information. I have a question about small caps, more particularly in Word.
Yep.
Why I'm asking, because when we do glossing, we're usually in small caps, and sometimes if we change the gloss, it would be nice to to be able to use regular expressions to change particular glosses
Yeah,
or particular environments.
yeah. Um, so small caps are probably a formatting inside some software like Microsoft Word. I'm not sure that small caps are Unicode characters. So, okay, so if they're Unicode characters, then you can deal with them just like any other character. But I suspect they're a formatting issue in software like Word. So I would be a bit careful with small caps. And I would always prefer to use Unicode characters rather than formatting for text that I wanted to use in various ways. So if you're just using it inside a Word document and you're formatting it, that's fine. But if you're doing something with it that needs to be put into an archive or sent around and used in different software, formatting in Word won't survive going through other programs. So you need to think about that.
Thank you.
Yeah.
Or if there are no other questions, maybe you
Yep.
can show us or say what your experience is with using regular expressions in ELAN or Flex, which is what a lot of people who do language documentation do. I don't know, there's probably a few.
Yep. Probably. So regular expressions are a feature of lots of different software. Let's see, I'm just going back to. So yeah, Flex, Elan, all of these tools have a regular expression function. And I'm just looking, there's a paper by Ulrika Mosel, which I've just gone past, which talks about using regular expressions in Elan. So people who use Elan for doing transcriptions can use regular expressions for searching in Elan as well, and Flex. So the thing is that it's a useful set of tools to know because you can use it in. Sorry, I'm just skipping through this here. So this is the paper by Ulrika Mosel, which looks at using regular expressions for linguistic purposes. So I would recommend doing that. I don't think I have a day where I'm not using regular expressions. They're in my work all the time. I'm doing some work now marking up. So this is an interesting project, marking up a grammar, text, and dictionary of Ngunnguborr. It's a project that I've been doing with Simon Musgrave, and it involves lots of searching through these documents and marking them using regular expressions to make them into hypertextual documents. There are many, many uses of regular expressions. So you've seen some. You've seen conversion of documents into different formats, and then you can imagine searching through documents looking for particular structures. So either looking for the number of words on either side, or if you wanted to look for words that had, consonant vowel, consonant vowel, consonant vowel pattern, for example, you could do that using regular expressions, and that would return all of them regardless of the content. It would be the structure of the word that you're looking for.
I wonder if I could ask about using regular expressions in programming languages like R and Python. I'm sure there are packages or modules for it, but I'm just curious which one you might recommend or where I might start in looking for those.
All programming languages use regular expressions. So R, Python, Perl, Java, all have regular expressions. That's what. So programming basically will deal with the same structure in countless situations and then do an operation on it. That's what a programming language essentially does. So the very basis for a programming language is a regular expression language. So I wouldn't be recommending any because they're sort of fit for different purposes. In linguistics, Python and R seem to be very popular, but it sort of depends on what you learn and what you like. But basically, when it comes down to it, there's a regular expression underneath all of them. Regular expression language underneath all of them. Okay, well, what I might do then, if I can find it, is show you this puzzle, since we've got a moment. So this is in the list of links that I sent you, and it's quite fun. So this is an online puzzle that you can do that helps you learn regular expressions. So what it does is you've got to insert the characters from the bottom here. So you've got E, H, L, and P. You've got to insert them into these boxes so that they satisfy both this expression and this expression. So in this expression, which is this one here, we've got not SPEAK in brackets and any number of them. So in this column, we've got to have characters that are not in SPEAK. And this also has to be characters that are, so this is saying HE or LL or O+. So looking for anything that's not in SPEAK and is in here, we can either have an L or an H, or we could have an O, but O isn't given to us down here. So at the moment we can't really tell which of these we want to put in there, so we'll go to the next one. The next one is either EP, IP, or EF. So E is looking good if we use HE, right? Because HE will give us the E there. So if we put in H here and E here, then we've satisfied both of these. There's no SPEAK there, and this is EP and EF. Now EF, this is saying we have to have a character from PLEASE. So F isn't in that expression, so it's no good. So we have to now only choose P. And in this one, we have to choose something that's in here, but is not in this word, in SPEAK. Now the trick is not to think of this as speak, right? It's the characters, SPEAK. So please, no, not please, PLEASE, whatever character's in there, but is not in the other one. So we can't do S and we can't do P, but we could do L. So let's try that. Yep, and we got it. So that's quite fun. If you want to have a play with that, that might help you with your learning of regular expressions. There are 10 puzzles that you can do there. So if there are no other questions, I suppose we've come to the end. I hope you've got an appreciation of what regular expressions can do. And if you've got any questions,